Okay, here we are with lesson 8, kind of a mystery here, linear equations in disguise. So in this lesson we learned that some equations that may not look like linear equations are in fact linear. So this lesson on solving rational equations is included because of the types of equations we will see in later topics of this module related to slope. We will recognize these equations as proportions. It is not necessary to refer to these types of equations as equations that contain rational expressions. They can be referred to simply as proportions since we are familiar with this terminology. Expressions of this type will be treated carefully in algebra as they involve a discussion about why the denominator of such an expression cannot be equal to 0. That discussion is not included in this lesson. Alright, so let's develop our concept. Some linear equations may not look like linear equations upon first glance. A simple example that you should recognize is x over 5 is equal to 6 over 12. So what do we call this kind of problem and how do we solve it? Well, this is called a proportion, and we can solve this by multiplying both sides of the equation by 5. We can also solve it by multiplying each numerator with the other fraction's denominator. So here is the theorem of cross multiplication, which actually was covered in 5th or 6th grade. Given rational numbers a, b, c, and d, so that b is not equal to 0 and d is not equal to 0, the property states that if a over b equals c over d, then a times d is equal to b times c. To find the value of x, we can multiply each numerator by the other fraction's denominator. So in this case, if we multiply according to the above, we would get 12 times x is equal to 6 times 5. It should be more obvious now that we have a linear equation. We can now solve it as usual using the properties of equality, which going on means that we would have 12 times x equals 30, and therefore x is equal to 30 divided by 12, or x is 5 halves. In this lesson our work will be similar, but the numerator and or denominator of the fractions may contain more than one term. However, the way we solve these kinds of problems remains the same. So let's do example 1 in your journal. Given a linear equation in disguise, we will try to solve it. To do so, we must first assume that the following equation is true for some number called x. We want to make this equation look like the linear equations we are used to. For that reason, we will multiply both sides of the equation by 2 and 4, as we normally do with proportions. So notice how we want to keep our expressions kind of grouped, so that is why we start including the parentheses. So this expression is being multiplied by 2, because 2 is the denominator of the other fraction. And this expression x minus 1 is being multiplied by 4, which is the denominator of the other fraction. So is this a linear equation, and how do you know? Well, it is a linear equation because the expressions on the left and right side of this equal sign are linear expressions. So notice that the expressions that contain more than one term were put in parentheses. We do that so we don't make the mistake and forget to use distributive property. So now that we have a linear equation, we will use the distributive property and solve it as usual. So again, copy down the rest of this process. You should be able to identify what properties are being used to step through each part of the process. The final answer is 7/3 is equal to x. Again, if there's any question about what's being done here, please make a note and bring it to class. So how can we verify that 7/3 is the solution to the equation? Well, we can replace x with 7/3 in the original equation. So going back to our original equation, if we plug that in the next step here, we get 7/3 minus 1 divided by 2 is equal to 7/3 plus 1/3 divided by 4. Then simplifying, we can do cross multiplying. 4 times 4/3 is equal to 2 times 8/3, which means 16/3 is equal to 16/3. So since 7/3 made the equation true, we know that it is the solution to the equation. All right, let's do example 2 in your journal. Can we solve the following equation? Explain. Well, we need to multiply each numerator by the other fraction's denominator. So, in doing that, we're going to multiply, and it doesn't matter if the 3 times the quantity of 1/5 times x is on the other side, whether these are transposed, it doesn't matter. So if yours is on the opposite side, just keep going. So what would the next step be? Now that we know that we have a linear equation, we use the distributive property. So now we have 7 times the quantity of 2x plus 9 equals 3 times the quantity of 1/5 minus x, turns into 14x plus 63 equals 3/5 minus 3x. So is this a linear equation, and how do you know? Well, yes, it is linear because the left and right side of the equations are linear expressions. All right, let's do example 3 on the worksheet. Can this equation be solved? Pause the video and see if you can find a solution. When you've finished trying, then go ahead and continue the video. So you should have said yes, we can solve the equation because we can multiply each numerator with the other fraction's denominator and then use the distributive property to begin solving it. And this is similar to what you should have. Again, the distributive property being used here, and then the rest of the time you're using the properties of equality. Your final answer should be 46 over 13 equals x. All right, example 4 on your worksheet. Can this equation be solved? Go ahead and try it, pause the video, and see if you can find a solution. All right, you should have said yes, we can solve the equation because we multiply each numerator with the other fraction's denominator and then use the distributive property to begin solving it. And you should have something that looks similar to this. The answer being 47/3 is equal to x, or x is equal to 47/3. All right, example 5. Begin by writing the ratios that represent the corresponding sides. That means you would set this up possibly as x minus 2 over 9/5, or 9 1/2 is equal to x plus 2 over 12. Is it possible to write several different proportions in this case? Can you name 3 other ways to write this ratio? So this might be one way to set up the comparison, but there are 3 other ways you could set this up and get the same result. Whichever way you have chosen, again, now that we had the ratios, solve for x and find the lengths of AB and AC. Here is just one solution based on what we mentioned earlier, but again, your problem could be set up slightly different. However, you should get an answer of x is equal to 17 2/10. From that, we can figure out that the length of AB is 15 2/10 centimeters, and the length of AC is 19 2/10 centimeters. All right, it's your turn to complete exercises 1 through 4. You can check your answer after each one if you wish, or you can wait until the end. But keep in mind that the process shown in the answers is only one way to do it. There are several variations depending on how you choose to show your work. Ultimately, you need to get the same answer in the end. So when you are ready to continue, go ahead and continue the video. All right, so the answer to exercise 1 is 1 over 7, or 1/7 is equal to x. For exercise 2, the answer is x is equal to 41 over 4. Again, if you're having any problems with understanding the process, please make a note and bring it to class. For exercise 3, here is a sample work. X is equal to -11/9. And for exercise 4, the answer is x is equal to 13/36. All right, so we know that proportions that have more than one term in the numerator and or denominator can be solved the same way we normally solve a proportion. When multiplying a fraction with more than one term in the numerator and or denominator by a number, we should put the expressions with more than one term in parentheses, so we are less likely to forget to use the distributive property. All right, we'll see you in class.